Basic experimental design. So experiments are key in finding the truth about how everything works in our world and methods to test hypotheses. So overall, it has three principles of the experimental design. Number one, control. So all experiments have some kind of control, placebo, for example, no treatment, etc. Second, principle of experimental design is replication. Large number of the samples usually lead to more accurate experimental result. Randomization, number three. So it's helped to eliminate bias in the result, make it more statistically significant. Blind and double-blind experiments also help to gain objective data. An experiment testing Echinacea tea as a treatment for cold. So we will talk about the experiment test. We will test hypothesis that this Echinacea tea can reduce the severity of the cold. So what is the experimental design? So it includes, for example, we will use 150 subjects, so this is clinical trial, for example, and we will randomly divide on the three groups. One will be control group and two groups will be experimental. So all 150 subjects experience only cold symptoms and all sound treatment from the clinic. 50 subjects from the control group receive placebo tea, not our Echinacea tea, once a day. And the other 50 subjects from the first experimental group, they will receive our Echinacea tea once a day. And 50 subjects from the second experimental group will receive Echinacea tea 3 times a day. Nurses and subjects are unaware of what type of the tea is used. So researchers can change experimental conditions. They are independent factors, variables. Result data, time of the illness are dependent factors or variables. So in here we can see results on this diagram. So we have result data. So first 14, 10, and 8. It's a day, time of the illness, this person was experiencing symptoms. In here, C is control, 1E, first experimental group, 2E, second experimental group. So this is show us different experimental conditions. And we will see that in the control group, so this is 50 patients who was drinking not Echinacea tea, but the other tea. So they were sick for about, in here when we look, 14 days. So what is this show? This is shows this line, standard error bar, plus minus. And it will be smaller if we will select not a 50 subject what we have, but for example 200 or 500 subjects. So this will be error bar small. So it means that from this 15 subject, yes, average, they were sick 14 days, but some was sick 9 days, and some maybe was sick, so maybe 20 days, yes. So in here, if we look on the first experimental group, we will see that on the average, they were sick 10 days. But again, some of them was sick maybe 15 days, and some 8 days. Yes, in here what we see, but average 10. In the second experimental group, when we look, we see that some of them was sick 8 days, but the other, so average 8 days, but some was sick maybe 11 days, and the other was sick maybe 6 days. So this is what in here shows. So this is this graph represent our data, our results. Now, what conclusion we can have? Conclusion that experiment support hypothesis, because our hypothesis was that this echinacea will reduce time of the symptoms, time of the sickness person, and this is what we can see. Then more tea they drink, like in this group, 3 times a day, and in here once a day, then less they on the average was sick.